In this episode, we continue our ES6 journey. In particular, we're going to take a look at the new and improved literal syntax, parameter magic as I call it, and classes. If you missed the first ES6 episode, go check it out if you've got the time. Okay, so let's dive in. So this is an old school literal. It represents a dog that has a master and that barks. There's also this weird dynamic attribute that's a combination between a string and a date with its value assigned to a random number used to represent the number of ticks the dog has on that date. Very contrived, I know. We're now going to start refactoring this to use the new and improved literal syntax. First up, literals can now infer the attribute name from the variable name. So we don't need to specify the master attribute name here. As you can see, it still has the desired attribute name in the result. With functions, we don't need to use the function keyword anymore. So when we remove that, it still works. We can also take this extremely contrived dynamic attribute and assign it in line. We just put the attribute's name in square brackets and use a colon instead of an equals here. See? Still works. This literal is more succinct and expressive than the old style, don't you think? We start off with a simple log function that spits out a message to the console. We want to adapt this to take an optional level parameter and default to debug level if no level is passed to it. First, let's add a parameter and use it in the console log statement here. Now when we run it, we get an error because we didn't pass the parameter in the function call. Currently, we would fix this statement by adding this line of code here, essentially giving level a value if it doesn't already have one. Now it works. In ES6 though, we can do this much nicer. We delete this line and just add the value onto the parameter here. That's way more expressive. Now we'll look at rest parameters and the spread operator. This is an adapted version of the function we used in the previous example. We want to adapt our log function to allow token replacement. We start by passing an array value to the function. When we run it, it's just ignored, as we expected. We add an args parameter and pass it onto the console log. We see it just wraps the array into the first placeholder here. The spread operator comes to our rescue here. It's used to expand an array in places where multiple arguments are expected. When we add these three little dots here, it works correctly. Let's do the reverse of spread for our function signature here. We don't want to pass in an array here. Let's make it multiple args and see how the function handles it. Not well it seems. It took the first value we passed in and spread out each character in the first argument. Although interesting, it's not exactly what we want. This is where we use what is called rest parameters. To fix this, we use the three dots again, but this time on the argument. And there we go. Rest parameters do the reverse of spread. It takes multiple arguments and wraps it into an array, which is usually much easier to work with in a function. I love this stuff. Classes are all about satisfying code that wants this sort of API. I think I might have upset a few OOP purists with that statement. Let's write some old JavaScript to satisfy this consumer code. Currently, there are a lot of ways to do this, none of which is embraced by the whole JavaScript community. I usually do something like this. I create a function with the arguments that I want on my constructor. Then I create an object literal and copy the arguments onto it. I also set the functions of my object on this literal. And lastly, return the literal. This works, but it's a bit weird, isn't it? Not only is it weird, it's just one of the 100 ways to do this. Let's rather change this code to use ES6 class syntax. We use the class keyword and remove the parameters here. We specify a constructor function that takes the expected arguments and set it on this. We refactor these functions to look like the functions of object literals we had earlier on in the episode. And it works! So much clearer what's going on here. I think this is probably most people's favorite feature of ES6. I still don't know how I feel about classes in general. But I think it's good that people who want to use them can model them as first-class constructs of the language. Class modeling was weird before ES6. But even worse was to model classes with inheritance. Let's adapt this example to exhibit inheritance. I'm creating a multi-choice question model and using the extends keyword to denote that it inherits from the question class. On its constructor function, I want an extra parameter containing possible answers to the question. Let's call it choices. Now, we want our code as dry as possible, so we want to reuse the question constructor if possible. Let's call the questions constructor by calling super. Super calls the function with the same name as the current one on the super class. Now we do what's specific to our class and store away the choices. In our ask function, we call super again. And then write out some code to spit out the options. I'm utilizing the ES6 for off syntax to loop through the items. I'm also using an ES6 string template to spit out the number for the option and the option itself. To get the number, I use this good old index of function on the array. I'm also going to remove this answer call for the moment. And we want to construct a multi-choice question class. Lastly, we pass some options to this function in an array. Let's go with yes, no, and not sure. Nice. You can see it reused the functionality it borrowed from the superclass without any weird code required. And that's it for this episode. We went a bit more advanced on this one, but ES6 has so much more in store for us, as I'm sure you'll see in the upcoming episodes. See you soon!